Hello, welcome to our new video. This video covers ionic lattice, a very important topic in chemistry. What is an ionic lattice? Ionic lattice means two things together. One, a very large number of ions are together. Another, the ions are regularly arranged. Let's start with a very common example, sodium chloride, which we know as table salt, and we eat it every day. Generally, we write the formula of sodium chloride is NaCl. But this formula doesn't represent the actual ionic lattice clearly, because this is an ionic compound, and ionic compound means that is a group of ions. But here you see sodium atom and chloride atom. No, they are not atoms, because ionic compound cannot have any atoms. They are ions. So more clearly, if we go for writing sodium chloride, you should write as Na plus and Cl minus, which means they consist of ions, and when we write simply a formula, we avoid the charges. In formula, we don't write the charges, but basically they have charges, as you see here, sodium ion and chloride ion. And also another problem is with the formula sodium chloride. Here it's shown that one sodium and one chloride, which is not true. Sodium chloride is a salt, is a lattice, consists of a very large number of ions. I'm going to show it. Here is a sodium ion and here is a chloride ion, and here I write another chloride, here also another chloride, giving you another chloride. So I'll give some sodium ions. Here is sodium ion, chloride ion, sodium ion, and chloride ions. Look at this. Now you see this is sodium chloride with so many ions. Actually, this consists of a very large number of ions, uncountable number of ions, which we cannot draw. We cannot draw all the ions in a piece of small lattice of sodium chloride. We just have shown some of the ions, and this is basically I've drawn a single layer of sodium chloride. Sodium chloride is a cubic structure, a three-dimensional cubic structure, and here you see just a layer. In this diagram we see a sodium ion, which is this, surrounded by how many chloride ions? 1, 2, 3, 4 ions, and one chloride ion surrounded by how many? 1, 2, 3 and 4 sodium ions. But basically in sodium chloride, one ion is surrounded by 6 of the opposite ions, which is not shown here because this is just a layer. The real lattice of sodium chloride you can guess if you consider this is a layer, and a layer is above this layer and another is behind this layer. Then there are layers of layers, and all together that is sodium chloride lattice. And in this lattice you will get one sodium will be surrounded by 6 chloride ions, and one chloride, each of the chloride ions will be surrounded by 6 sodium ions, and that is actual sodium chloride lattice. And now let's try to draw actual sodium chloride lattice, which is actually difficult to draw all the ions together, but we're going to show the small unit of the lattice. In order to drawing of actual sodium chloride lattice, we start drawing a square. This is a normal square I've drawn, and if I copy and paste this 3 times, what I get? I paste this and I paste this again. And now I'm gonna connect the corners of the square. Here you see, here, and this. What's next? Each of the lines, suppose this is a line, has a certain midpoint, and this also will have a midpoint. Consider this is the midpoint. I'm going to join these 2 midpoints. So similarly, I'm going to join midpoints of all the lines. Here you get this for this, for this. When I've drawn the midpoints, I get some small lines, and which are basically parallel to all other small lines. And next I'm going to join the points of the small lines. Here you see how I do this, and here's the midpoints, and here's another. For this, the midpoint, and here's the other. Okay, look at this, another point I join here. This is So this is the basic structure of a lattice of sodium chloride. Still sodium ion and chloride ions are not there, they're still missing. So we want to represent sodium ion as this sign is blocked dot, and chloride ion as this empty circle. So let's start middle. We put sodium in the middle, which is surrounded by, as you know, 6 chloride ions. I'm going to show how 6 chloride ions of chloride surround this sodium ion. This is 1, 2, 3, 4, 5, and 6. Look carefully. In the middle ion is sodium, which is surrounded by 6 chloride ions. And in the lattice of sodium chloride, chloride ion is also surrounded by 6 sodium ions. That we can also show here. So look at this. This is a chloride ion. I'm going to surround this with 6 sodium ions. Here is 1, 2, 3, 4, and one is behind this ion, and another will be above this ion. If I draw another layer before this layer, then we'd get another sodium ion. And I'm going to complete the diagram putting all the sodium ions and chloride ions alternatively. Now again we look at the formula of sodium chloride, which we simply write as this. When you write this sodium chloride, this formula actually fails to represent that this consists of ions. So really they should have ions. And when you write ions, and that also fails to represent the number of ions. Actually nobody knows the ion number of ions in a piece of lattice of sodium chloride, but there are layers that we can show with a single layer of sodium chloride. And here we get the actual figure. Here we see each of the sodium ions surrounded by 6 chloride ions and vice versa. So this is lattice of sodium chloride. And if you think ionic lattice of all other compounds also have ionic lattice structure in their solid state. For all other ionic compounds, a lattice structure is like this, but they may differ because the arrangement of the ions are not exactly same in the lattice. This concept of ionic lattice can explain the properties of ionic compounds. Ionic compounds are good conductor of electricity only in liquid state or when they dissolve. Ionic compounds are very good conductor of electricity only when they are liquid or they are dissolved in water. Here you see in solid structure they are closely packed. The ions are regularly arranged. The ions themselves cannot move to carry electric charge. Not only sodium chloride, any ionic lattice, any ionic compounds cannot conduct electricity in solid state. But if you dissolve them, the ions get disordered, the ions can move about freely. And also this happens when you dissolve this in water, ions get free to move about. Then liquid ionic compounds can conduct electricity. The electrostatic attraction between any two oppositely charged ions are very strong. And when you consider the ionic lattice, that means the electrostatic attraction is not just between two ions. One is attracted by 6 others here in sodium chloride and vice versa, which means their electrostatic attraction there in the lattice is huge. So in order to melting or boiling this type of compounds, you need to break or weaken the electrostatic attraction, which is very strong in the lattice. So generally ionic compounds have very high melting and boiling points. With this concept of ionic lattice, we can also explain the other property of ionic compound, which is ionic compounds are brittle. They are very hard, but they're brittle. Under stress, the lattice breakdown. If somehow you push these 2 rows, what would happen? These 2 rows move towards right, and look at the change in the arrangement. And this new diagram, what we see, if these 2 rows move slightly towards right, here you see these 2 ions of same charge get together. Same for chloride, sodium ions. So what will happen? Electrostatic repulsion. There will be electrostatic repulsion. They repel each other and the ions split, which means the lattice will split away. For 2 reasons, the structure of ionic lattice of different ionic compounds are different. One is a ratio. In sodium chloride, we get sodium ion and chloride ions are equal, which means the ratio of sodium ions to chloride ions 1:1. So here's we get a structure of the lattice, and if the ratio is 1:2, suppose this is for calcium chloride, I write the formula of calcium chloride CaCl2. So clearly you see that chloride ion is double than calcium ions. In the lattice of calcium chloride, you will get double number of chloride ions than calcium ions. So the arrangement of ions at the lattice of calcium chloride cannot be exactly the same as sodium chloride. And the other reason for different lattice structure is the relative size of the ions. In sodium chloride, the relative size of sodium and chloride are close. I mean, chloride is bigger, but not that much bigger than sodium. But if this is another compound, we consider cesium chloride, cesium and chloride. Here you get the lattice structure will be different than sodium chloride, because the cesium ion is much larger than sodium ion, which means a greater number of chloride can fit around cesium ion. These are all about ionic lattice, and I think this video has made your concept of ionic lattice very clear. And if you really like this video, like our class, just stay with us. I will get more classes of this type. Thank you very much.